Hey guys, we are looking at Module 4, Homework B, Tab 3, Part 3, and this is the electric potential of the innermost sphere. So the total electric potential, V1, at the surface of M1 is influenced by the charges on all three metal objects. So let's go ahead and take a look at the electric potential due to M1. So the potential due to M1 itself at its own surface is given by capital V1, comma, self is equal to K times Q1 all divided by R1. And now let's go ahead and take a look at the electric potential due to M2. So the electric potential inside of M2, considering that the potential inside a spherical shell due to the shell's charge is constant at all points within the shell, is going to be V2 R is equal to K times Q2 all divided by R21. And this is for R is less than R21. And for the points between R21 and R22, that's going to be, I'm going to go ahead and restart this. For points between R21 and R22, we're going to have V sub 2 of R is equal to K times Q2 all divided by R21. That's constant within the shell. So now let's go ahead and take a look at the electric potential due to M3. So the potential inside of M3 for R is greater than R31 is going to be V3 of R is equal to K times Q3 all over R31. And for points between, I'm going to go ahead and write this, points between R31 and R32 is going to be V sub 3 of R is equal to K times Q3 all over R31. That's constant within the shell. Let's go ahead and write this with better writing. Okay, so let's combine the potentials now. So to find V1 at the surface of M1, which is our radius 1, consider the contributions of each of the cells. So we have potential of R1 due to M2. So the potential due to M2 at R1 is influenced by the fact that M2 contributes to V2 of R1 is equal to K times Q2 over R21. And the potential of R1 due to M3, and that's going to be the potential due to M3 at R1 is going to be V3 R1 is equal to K times Q3 all over R31. So given that M1 is surrounded by M2 and M3, to correctly calculate V1, we need to account for the following. First thing is the contribution of M2. At the surface R1 due to M2 from the inner surface of R21 to R22, the potential should be K times Q1 plus Q2 all divided by R22, and that should be actually minus, not plus. K times Q1 plus Q2 all divided by R31. And the second thing is the contribution of M3. At the surface of R1, considering the potential form M3, and it's going to be K, and then it's Q1 plus Q2 plus Q3 all over R32. So if we combine all of these, the correct expression for potential V1 at the surface of surface M1 is going to be V1 is equal to, or that's not R, K times Q1 plus Q2 all divided by R22 minus K times Q1 plus Q2 all divided by R31. And all of this entire thing is going to be added to, I didn't realize I was writing so big, K times Q1 plus Q2 plus Q3 3 all over R 3, 2. Let's go ahead and write this K better. And that should be the final thing that you put into Snape Physics. I hope this helped.